Okay, let's do some math one. Today we are going to solve this rational quadratic inequality. Now to solve this quadratic inequality is pretty simple. So you just multiply x plus 3 times x plus 5 to here, and then 0 times x plus 3 times x plus 5. And so it's going to be x minus 2 times x minus 5 is going to be bigger than 0, and then you plot the graph. So you plot the quadratic graph. So the root is 2 and another root is 5, and then you are going to just plot the parabola, and then we are going to define the region that is bigger than 0. So the answer is x is less than 2 or x is bigger than 5, and we are done just like that. Okay. Now, someone just tell me that this is wrong, but I don't see any mistake because I have x plus 3 and x plus 5, and then I can just multiply to other side, and then what remaining is the x minus 2 times x minus 5 is going to be bigger than 0, and you plot the parabola, then you get the answer, right? But someone just tell me that this is wrong. Where is the mistake? Okay, I will stop messing around. Okay, now here is the mistake. Now when it comes to multiply or divide a constant, you are just going to be just multiply or divide, and it depends on what kind of constant that you are multiply or divide. If you are multiplying a positive number, then you don't need to change the inequality sign, right? But if you multiply a negative number, then you must change the inequality sign, right? So now here's the thing, that is just constant. But when it comes to variable, when it comes to expression, you cannot just simply multiply or divide. You must make sure that the expression that you are going to multiply or divide is going to be positive or negative at all time, which means that it's going to be positive for all real values of x or negative for all real values of x, which means that when you plot the function, or when you plot the graph of the function that you need to divide or multiply, it is going to be always above the x-axis or below the x-axis. So that's why you can just multiply to there, and before you determine when you not determine whether the expression is going to be always bigger than 0 or less than 0, because right here we got the function for x plus 3 times x plus 5, right? So x plus 3 times x plus 5, when you plot that, you should get a parabola. But since this is we got two roots, then you have one positive part and one negative part, which means that it is not going to be positive or negative or for all real values of x. It depends what kind of value of x that you substitute, because sometimes you can get positive, sometimes you can get negative. So we cannot just simply multiply or divide. We have to make sure that this is positive or negative at all time. So how are we going to solve this rational quadratic inequality when we literally cannot multiply or divide the bottom part? So here is the two method. So now this is the first method. The first method is you need to plot y is equal to x minus 2 times x minus 5 over x minus 3, x plus 3 times x plus 5. So how are you going to plot this kind of ridiculous thing? Now this is what we call the reciprocal or rational function. And when you have an expression on the bottom, this tells you what? This tells you to find the vertical asymptote. So we will kind of try to plot the graph. We just roughly sketch the graph. Now when we find the root of this, it's going to be negative 3 and negative 5, and this is our vertical asymptote. So this is the vertical asymptote. And then what you're going to find is the horizontal asymptote. So if you want to, in order to find horizontal asymptote, you are going to be set the limit as x approaches infinity of y, or n the limit as x approach negative infinity of y. These two will define will find the horizontal asymptote. So, and then when you do this by using your mind or whatever, you are going to get one, both of one. Yeah, both are one. So what I can say is the horizontal asymptote is going to be 1. So this is our horizontal asymptote. And then what we're going to do is we are going to find the roots of this rational function. Now, so we are going to set this equal to 0. And then we are going to multiply to the other side. Now this time we can legitimately multiply this bottom part to the other side. So you don't need to worry everything. And then what we're going to do now is x minus 2 times x minus 5. So we are going to set this equal to 0 because when you multiply the bottom part at other side, you just get 0, right? So you just don't need to waste time and write all this. So, and then when you do your mind, you will get 2 and 5. So this 2, this is 5. And then you kind of find the y-intercept, but don't really try to find because I already know what kind of graph you have. So your graph is going to be something like this. Nah, this is too ugly. Let me just draw this again, like this. Now, why I draw like this? Because as x approaches infinity is going to be 1, which means that I need to draw like this. It's because this indicates the horizontal asymptote, and you are just going to draw like this. I'm sorry if the graph is really ugly. Let me draw this once again. So you got what? You got negative 5 and negative 3. You got the horizontal and vertical asymptote, and then this is 1. This is 2, and this is 5. And then we are just going to plot the graph, so you will get something like this. And this is the graph of x minus 2 times x minus 5 over x plus 3 times x plus 5. Oh my god, this is quite hard to plot. And then what I'm going to do is you need to define the curve above the x-axis because bigger than 0. So our curve is this part, and this part. So we need to define the curve that is highlighted with orange marker. And so here is the final answer. The final answer is going to be x is less than negative 5. Don't put bigger than or don't put less than or equal to, because as you can see the function is not continuous at negative 5 and negative 3. So we cannot just simply put the bigger than, because if you put bigger than, then it is going to be very, very bad. Because if you put bigger than or equal to, when you plug in when you plug in exactly negative 5, I'm going to give a sad face because that's a really, really bad sign in math. So this is the first one. The second one is x is in between negative 3 and 2, because we got this right. And then you don't define this because this is going to be lower than the x-axis, so you don't need to worry about it. And then the last one is x must be bigger than 5. And this is our final answer. And if you watch my video about solving simultaneous quadratic inequality, this is the exact same result. I just used the inequality on that video to make this thing. And but this is just the first method. Now, if you don't know how to graph a rational function, now this second method is going to be perfect for you, because it is going to be 100% effective. Okay, now this is the second method that I'm going to show you to solve a rational inequality like this. Now, x minus 2 times x minus 5 over x plus 3 times x plus 5 is going to be bigger than 0. This tells us what? This tells us that x minus 2 times x minus 5 over x plus 3 times x plus 5 must be positive, must be a positive number. So we just indicate this is positive number. And remember what we know about positive number. Now let's say when you have two things, a over b must be bigger than 0. It's a positive number, right? Because it's a positive number. Then you got two cases. It's either a is going to be bigger than 0, b is going to be bigger than 0, or a is less than or equal to 0 and b is less than 0. A is less than 0, not a is less than or equal to 0. Because a is bigger than 0 means it's a positive number. B also a positive number. So positive divided by positive, we get a positive number, which means it's going to be bigger than 0. If a is a negative number, then b is also must be a negative number, because negative divided by negative, you will eventually get a positive number, which means it will be bigger than 0. So we got smile face. So let's use this strategy to solve the inequality. Now, x minus 2 times x minus 5 over x plus 3 times x plus 5 is going to be bigger than 0. So we got these two cases. So x minus 2 times x minus 5 must be bigger than 0, and x plus 3 times x plus 5 must be bigger than 0. Or x minus 2 times x minus 5 is less than 0, and x plus 3 times x minus 5 is less than 0. Now here's the thing. Now when we plug in number, we must make sure that this and this must be positive at the same time, because if it's positive at the same time, then this divided this will eventually get positive, which will eventually solve the inequality, satisfy the inequality. And then the same case like here, if you put a value inside this such that it is this is negative and this is negative at the same time, so negative divided by negative, you will get positive, which is bigger than 0, or positive, you get positive number, and we got smile face once again. So in order to guarantee that when we plug in value that satisfy this and this at the same time, or this and this at the same time, solve the system of inequality. And I already show you how to solve this at the previous video, but I am going to show you once again.
Now if you solve this, you just draw the parabola. Now let me just draw two parabola. Now this is the first one, x minus 2 times x plus 5. So this is 2, this is 5, and this is going to plug this. And this is the parabola. This is x minus 2 times x minus 5. And you got another one right here. So x plus 3 negative, yeah. So another one right here. Negative 3 and negative 5. And that's like this. Now this is for this and this is for this. And then what we do is define the curve that such is positive. So for this it's going to be x is bigger than 2, or x is less than 2 and x is bigger than 5. And then for this is x is less than negative 5, or x is bigger than negative 3. And then we're going to plug this on the number line. So negative 5, negative 3, 2 and 5. So x is less than negative 5, or x must be bigger than negative 3, and x is less than 2, or x must be bigger than negative, or x must be bigger than 5. And then going to define the overlapping region. So the answer is going to be x is less than negative 5, x is in between negative 3 and 2, and x is bigger than 5. So this is the first one. Now,
this is the first one, and I need to check for the second case again, isn't it? For this. Now, for this one, it is really simple. because we already got the graph. So x is going to be in between 2 and 5, and x is going to be in between -5 and -3. So when we plot the number line, we get -5. Right. So we got -5, -3, 2 and 5. Now x is going to be in between -2 and 5, and the other one is x must be in between -5 and -3. Now here's the thing, do we have an overlapping region? No. Do we have to combine the region? Yes, but we don't have the overlapping region. We don't have, right? So our conclusion is the range of x is undefined for this system of quadratic inequality, because we don't even have the overlapping region that will satisfy both at the same time. So we have no range. We have no range of x. We have no range of x for this one. So our remaining answer is this. So this is our final answer. So x is less than -5, x is in between -3 and 2, and x must be bigger than 5. So this is our final answer. So this is the second method. So this is second method to solve a rational inequality, and the result that you get is a pretty nice result. And I hope you guys learned something new in this video, and if you enjoyed this video, leave a like and subscribe to my channel for upcoming math videos, and I will see you guys next time.